Hi everyone, welcome back. I'm Dr. Surjit Singh. Today we'll talk about the Leetcode problem, diameter of a binary tree. It is an easy and interesting problem. Let us begin. We are given a binary tree. We are to find the diameter of the tree, which is the longest path between a pair of nodes of the tree. In all such problems, we always prefer DFS approach to process all nodes recursively. Let us quickly understand the problem. Diameter of this tree is 0, while for this tree diameter is 1, and for this tree it is 2, because the longest node to node distance is 2. From the root node, both the left and the right branches of the tree each contribute 1 to the diameter. Now consider this tree. Length of the left branch is 1 and that of the right branch is 2. So the diameter of this tree is 3. It means that from node 7 to node 1 there are 3 edges. For further discussion, we will consider two subtrees separately. Left subtree has height 0, so with the root node included, the length of the left branch is 1. For the right subtree, height is 1, so adding the link with the root node, length of the right branch is 2. So the diameter of this tree is 3. Other option also gives the same result. Diameter of the tree is the largest of these lengths. It is clear that to find the height of the subtrees, we will follow DFS to recursively process every node of the tree. In this tree, length of the left branch is 1, height of the right subtree is 2, so with root included, length of the right branch is 3, so the diameter of this tree is 4. The other path has length 3, so it cannot be called diameter because it is less than 4. So our method is now clear to us. We will find the height of the left subtree and add 1 to it to include the root node. Then find the height of the right subtree and add 1 to it. Diameter of the tree is the sum of these two values. But we must also consider the situation in this tree. With 8 as the root, diameter of the tree is 5, while if 9 is the root, the diameter is 6. So we will consider each node as the root recursively and find the diameters. Largest of these is the final value of the diameter. Let us now write the Python program for this. 8 is the root node, so we need the variable named diameter, which is accessible to all calls of DFS. Hence we define it outside the recursive DFS function called longest path and declare it as non-local inside the function. In the main function, we initiate a recursion with the root node. First, we check the node in the recursive function. If it is none, we return 0. 8 is not none, so we proceed further. We find longest path of the left subtree, for which we process the left subtree of node which is 7. 7 is not none, so we proceed further. We notice that 7 is a leaf node. Left node of 7 is none, so we directly return 0, which we save as longest left path of node 7. Right node of 7 is also none, so 0 is saved in longest right path also. Same is true of all the leaf nodes. Sum of two paths is compared with the non-local variable diameter. Both are 0, so diameter is unchanged. We add 1 to the longer of these two paths to include the edge linking it with the root node. We return it and the longest left path of 8 becomes 1. We now proceed to find the longest right path of 8, for which we make a call with node 9, which makes a call with its left node, which is 1. This further makes a call with node 3, which then makes a call with node 2. 2 is a leaf node, so both of its values are 0. Their sum is 0, so it does not affect the diameter. We add 1 to the higher value of these and return it. This incorporates link from node 3 to 2. We save it as the longest left path of 3. Right node of 3 is none, which returns 0 to its longest right path. The sum of these two paths becomes new diameter. Higher of these paths is 1, so we return 2 and store it as the longest left path of 1. Right node of 1 is none, so its longest right path is 0. Sum of 2 and 0 is more than diameter, so new value of diameter becomes 2 and we return 3, which is stored in longest left path of 9. Right node of 9 is 5, which becomes node in the next call. Its left node is none and its right node becomes new node. We can easily visualize that the longest left path of 6 is 1 and its longest right path is 0. Their sum is 1, which is less than the diameter. 2 becomes the longest right path of node 5. There is no change in diameter. 3 is the return value, which we save as longest right path of node 9. The sum of the two paths of node 9 is 6, which is greater than the previous value of diameter. So 6 becomes the new diameter. Higher of the two paths is 3, so 4 becomes the longest right path of node 8. Sum of two paths is now 5, which is less than the latest value of diameter. We increase 4 by 1 and return 5 to the main function. The main function returns the final value of diameter as the solution. Time complexity is of the order of n because all the n nodes are processed only once in DFS. Depth of the call stack is equal to height of the tree, for which maximum value is n, which becomes the space complexity. Hope you enjoyed the video. Thank you all for your time. Stay tuned for more.